tower? Please explain with the help of diagram. Take one example to solve the problem on heat balancing with the help of psychrometric chart, and why makeup water is required for the cooling tower. Let us first understand how the heat balancing is taking place in the cooling tower. For that, we have to refer all the elements that are entering inside the tower and leaving from the tower. Now here air is entered from the atmosphere. Now this air entered from the atmosphere because of these induced fans, and motor is attached to the induced fan. Then the hot water is also getting entered inside the tower. Then air leaving from the tower as well as water is also leaving from the tower. So how we can take this heat balancing process? So heat, that is the heat of air at inlet plus heat of water at inlet plus motor attached to this induced fan. So it is inside the tower. So we have to also consider the heat dissipated by motor, which is equal to heat of air leaving the tower plus heat of water leaving the tower. Now we will understand this with the help of formula. So here how we can define the heat of air at inlet. So here we have to take the mass of air multiplied by the enthalpy of air at the inlet. So here Ma into Ha1 plus total heat of water at inlet. So again we have to take mass of water multiplied by the enthalpy of water at the inlet, that is Mw1 Hw1 plus heat dissipated by motor, we will refer here as a Q, which is equal to now heat of air at outlet. So here air is outlet. So again we have to take the mass of air multiplied by the enthalpy of air leaving the tower, that is MaHa2 plus heat of water at outlet. So here for this we have to understand there is the evaporation of water when the hot water entered inside the cooling tower, and some water vapors are carried out with the air leaving the tower, and that's why makeup water or quantity of makeup water is required, because of the water vapors are carried out the air leaving the tower. So how to decide that is the what is the amount that is leaving with the air? So for that we have to compare the specific humidity of air entering the tower and air leaving the tower. So when we compare this, when the water vapors are carried out with the air, then here specific humidity of air leaving the tower is higher than the specific humidity of air entering the tower. So we have to find out this difference in specific humidity, and when we multiply with the mass of air, then we will get the actual amount of the quantity of makeup water that is getting required. So if we subtract this quantity of makeup water, then we will get this Mw2. So how to find out this Mw2? That is the total water entered inside the cooling tower minus the amount of water vapor that is carried away with the air. Then we will get the remaining water that is taking out from the tower. So here we have to take that is Mw1 minus, we have to take Ma, that is the mass of air, multiplied by omega 2 minus omega 1, that is this is the value of specific humidity at point 2 and 1. Now this value is given in gram per kilogram, but standard unit is kilogram per kilogram, so we have to take here as a 1000, and for this whole bracket we have to multiply with enthalpy of water leaving the tower, that is Hw. Now we will simplify this. So for that we will first take this Ma, that is the mass of air, as a common term. So this Ma is common. If we observe, here is Ma and here is Ma. Now for this bracket we have to multiply with Hw2. So when we solve the bracket, then here is also Hw2 and here is also Hw2. So I will write here. So here is also Hw2. So inside the bracket there is Hw2. Now a common term. So here if I take MA as a common term, then I will take HA2. Then if I take this to the right hand side, then it will become HA2, this plus sign will become minus, that is minus HA1, and then minus omega 2 minus omega 1 by 1000 into HW, which is equal to, now we will take MW1 as a common. So MW1 is here, it is here. So for this MW1 I will transfer this MW1 HW2 to the left hand side, then it will become MW2 as a common, then HW1 minus HW2 and plus Q as it is. So here this is the formula. So how to apply this formula? So for that we will solve one problem. So I will read what is the given question. A small size cooling tower is designed to cool 400 kg of water per minute. The water enters the tower at 43.5 degrees Celsius. The air enters the tower at 18.5 degrees Celsius and 60% relative humidity, and it leaves the tower at 27 degrees Celsius and in saturated condition. The motor driven fan forces 600 meter cube of air per minute through the tower and power absorbed is 4 kilowatt. Find temperature of water coming out of tower and makeup required per hour. So this was the given question. Let us first understand what is the given data. Now it is given that the mass of water entering inside the cooling tower is 400 kg per minute. Then the temperature of water at inlet is also given, TWI 43.5 degrees Celsius. Then when the air enters from the atmosphere, then it is given that temperature is 18.5 degrees Celsius and 60% relative humidity. And when the air leaves the cooling tower, then the air at outlet is given that 27 degrees Celsius temperature and it is at saturated condition. Then the volume of the air is also given. So when the air is entered, volume is given 600 meter cube per minute. And the power absorbed by the motor which is attached to the induced fan is also given as a 4 kilowatt. So from this given data we have to first find out the different values. That is, we will first plot the point 1 and point 2 on the psychrometric chart for the initial condition of air and final condition of air. So when air from the atmosphere enters inside the tower, then this is the initial condition of air. And from this initial condition we will plot the point 1 on the psychrometric chart. And when air leaves, that is 27 degrees Celsius and saturated, that means 100% relative humidity. So this is the final condition and from this we will plot the point 2. Now if we observe the formula, then here it is given that MA, that is the mass of air. So how to calculate the mass of air? So formula is V by Vs1. V is the volume that is given and Vs1, that is the specific volume of air entering the tower. So from the psychrometric chart we will first find out what is the specific volume related to this point 1. Then we will find out the enthalpy at point 2 as well as enthalpy at point 1. So here with respect to these 2 points we will find out HA2 as well as HA1. Then we are also going to find out the specific humidity, that is omega 2 and omega 1. So this omega 2 and omega 1 is given in grams per kilogram, but standard unit is kilogram per kilogram, so we will take here divided by 1000. So all these values, that is this enthalpy, specific humidity and specific volume, we are going to find out with the help of the psychrometric chart. Now this MA, that is the mass of air, is V by Vs1. So this V is given in meter cube per minute and specific volume is given in meter cube per kilogram. So if we observe here, unit of the mass is kilogram per minute. Now the heat dissipated or the power absorbed by the motor is given 4 kilowatt. So kilowatt means kilojoule per second. So I will write here, it's a 4 kilojoule per second. But here for this mass it is given kilogram per minute. So again we have to convert this in kilojoule per minute. So in 1 second, amount of the energy is 4 kilojoules. So for 1 minute we have to multiply here with 60, that is Q is equal to 4 into 60 kilojoule per minute. So we have to take this term, this value of Q 4 into 60, because we want all these values for the per minute value. This is the psychrometric chart, and we have to plot the point 1 and point 2 as per the given data for the air entering to the cooling tower as well as air leaving from the cooling tower. Now, for this initial condition of air, dry bulb temperature is given 18.5 degrees Celsius. So we have to take here one approximate line, vertical line at 18.5 degrees Celsius, and relative humidity is given, that is 60%. So here relative humidity is given 10%, 20%, 30%, and here is the line with 60%. And dry bulb temperature is also given on this horizontal line. So I will extend this line up to 60% relative humidity. So here is the point. So this is the point 1. Now we will select the point 2. So it is given that 27 degrees Celsius dry bulb temperature and saturated condition. So what is the meaning of saturated condition? That means 100% relative humidity, and here is the line with 100% relative humidity, or we can say that saturated condition. So again, I will draw here one vertical line with 27 degrees Celsius and saturated condition. So here will be the point 2. Now we have to find out the different values at this point 1 as well as point 2. Now for this point 1, we will find out first enthalpy. So what is the value of enthalpy? So we will draw here one parallel line to this enthalpy line. So if we observe here, this is the red line indicates the line for enthalpy as well as wet bulb temperature. And if we observe here, the note is given enthalpy lines overlap wet bulb temperature line. So same line indicate the enthalpy as well as wet bulb temperature. Now for this point 1, if I draw here one parallel line to this enthalpy line, then what is the value? It is slightly below this 42 kilojoule per kilogram. So we can say that it is 38.87 kilojoule per kilogram. That is the value for this enthalpy at point 1. Then what is the value for specific humidity? So for that, I will draw one horizontal line passing through this point 1. And here is the value. So this value at this point is 7.8 grams per kilogram. That is the value for specific humidity. Now we will find out what is the value for this specific volume. So we have to take the same unit as mentioned in the psychrometric chart. Now specific volume is given with the help of this green color. So here is 0.90, 87, 0.85 and 0.83. Now this point is in between 0.83 and 0.85. So if we draw here one parallel line to this green line, then the exact value is 0.836 meter cube per kilogram. Now we will move for the point 2. So here is the point 2. At this point, what is the value for enthalpy? So we will draw here one line parallel to this enthalpy line but passing through this point 2. Then what is the exact value? So it is in between 75 to 98 kilojoule per kilogram. So exact value is 84.85 kilojoule per kilogram. Now we will find out what is the specific humidity. So from this point 2, I will draw one horizontal line passing through this point 2. So here, what is the value for specific humidity? So it is slightly below this 25. So exact value is 22.6 grams per kilogram. So these values we have to note down. Now we will put all the values. So if we observe here, we will put what is the mass of air, that is V by Vs1. So V is given 600 divided by specific volume of air 0.836. Now this enthalpy 84.85 minus 38.87 minus we will take specific humidity 22.6 minus 7.8. Now this value is given in gram per kilogram. So we will divide here by 1000 multiplied by HW2. That is the enthalpy of water leaving the towel. So for this HW2 means what? That is the specific heat multiplied by the temperature. That is CPW multiplied by temperature of water leaving the condenser, leaving the cooling tower. So here Cp is 4.2, that is specific heat of water. We have to take 4.2 multiplied by the temperature of water, that is TWO, is equal to again MW1. So this MW1 is also given, that is when the water is entered inside the tower. MW1 400 multiplied by, now here HW1 minus HW2. So here we have to take Cp TWI minus Cp TWO. So TWI is the temperature of water at inlet and TWO temperature of water at outlet. So here Cp we have to take as a common, that is 4.2, and temperature of water at inlet TWI is given 43.5 minus TWO, that is unknown, plus Q. So plus Q we have to take 4 into 60 because we have to take in kilojoule per minute. So if we observe this, only one unknown term, that is TWO, that is the temperature of water at outlet, and it is equal to 32.65 degrees Celsius. Now we will move for the second question, that is we have to find out the makeup water. So for this makeup water we already know the formula, V by Vs1 omega 2 minus omega 1 by 1000. So if we observe, here is omega 2 minus omega 1, that is 22.6 minus 7.8 by 1000. And what is the value of V? That is 600, and Vs1, so Vs1 is also given, that is 0.836. So when we calculate this, we will get the answer 10.6 kilogram per minute. So this is the quantity of makeup water that is required for this cooling problem.